Hello and welcome back. One of the most prominent stage of any metaheuristics algorithm is initialization. So let's get started with this stage, which is so important. In initialization, generally speaking, we just generated a solution randomly. So it's depend on our problem. Our initialization would be quite different. For this problem, we just wanted to initialize a binary variable, so it would be just between 0 and 1. So the main question is that how we can store the information related to the initialization in our pub. So the answer would be a structural array. So what is the structure array? Actually, we have a position and we have also cost. This position related to our solution representation. Actually, this is our solution representation or our answer, and this would be x, and this is our y, or this is a fitness function, and this feature is related to the pub. So how we can just store this feature for any pub. This would be used through a structure array, and this is our definition of a structural array. A structure array is a data type that's group related to data using data containers called field. Each field can contain any type of data. Access data is a field using dot notation of the form of a structure named dot field name. So for any given structure, we have this structure here, the name of a structure dot the field name. So we can use different fields for any pop. So here we just want these two fields here, the position and cost. So first of all, we have to randomly position, and then we have to use a fitness function to evaluate this position and store this value into this cost. In general, we have a pop and we have a position and we have a cost. So first of all, we have to randomly generate the position based on the binary variables. So we have a pop, and this pop have two different features, and the first one is a position that we just wanted to store our solution to the position that can be binary variable, and the second one is just fitness function, and this is just directly related out of our position. So we have to evaluate this position and store the fitness function into the cost. So let's just go to our codes and see what we can do. Here we have to go to the BGA, our code, our script, and define the section as the initialization. So here we define the initialization. Just save it. At first, we have to take a look at the structure array. So suppose that we have a name dot a, which we equal the name dot a, which is 10, and name dot b would be 11. So here we have a name that's as a struct. So once we just go to the name, we have two fields here. The first one is a and the second one is b. So just CLC, use CLC here, and name. For the name, we have a struct. So we have two fields here. A would be equal to 10 and B would be equal to 11, and we can directly access this field by this code name.a or name.b as name.b. As you can see that this is a so effective structure that we can just access our data, so we can use for population to store position and cost. So let's just go to our code. At first, we have to define empty pop here. So we have a code these two fields here as a empty pop. Empty pop dot position would be equal to empty, and this would be FN for cost. So we have defined the empty pop with two fields here. So at At the next, we have to use a rep map function. What is rep map function? Actually, once we just wanted to apply different structure for the different population, we can use this kind of function. So suppose that we have a matrix such as this. So this is a matrix, the size 2 by 2, and we just repeat it for the other size of the matrix. So we can use repmat m with different size, for example 3 by 5. So as you can see that we just repeated this matrix to the other bigger matrix with the size 3 by 5, so it's just repeated with 3 rows and 5 columns. So we can use this structure, we can use this function in our code. So let's just get back our code. So here we have to use repmat here to repeat this struct to the population. So pop would be repmat, and we wanted to repeat this structure with the size and number of population and 1. So let's just save it and try this code here. As you can see that we have a empty pop here as a struct. We have two fields here, position and cost. If we just go to the pop, we have a different structure here. We have 20 pops with different position and different costs. As you can see, they are empty and there is no value here in this field. So let's just get back to code and initialize firstly the position part, and then with respect to the position we can define the cost. So to initialize our positions, we can use a loop. So this loop is just repeated based on the number of population, because we have a 20 population here, and you know that loop is just for repeated tasks, so we use the loop here. Loop 4 would be started, this loop would be started with 4 and ended with end, and here we have to define the I here, which is equal 1 to n pop. And here pop I that position would be, and it could be assigned here by rand I. What is rand I? Rand I is just randomly generated any integer number between two numbers. So here we just wanted to randomly generate it between 0 and 1 with the size of n var here that we just defined here at the start of our code. So would be something like that, rand e between 0 and 1 and n var. Just save our code and let's see what's happened. Just run BGA. As you can see, if we just go to the pop, we can see that all positions are randomly generated. So we have to evaluate this position with respect to our cost function. So just get back to our code here, and here pop I that position, that cost, sorry, would be cost function, and this cost function has one input, and this input would be pop I dot position. So let's just save it and try what happened. We just CLC clear. We just wanted to clear all workspace here, and again run BGA. As you can see that we just missplit in min1, so we have to modify our quotes min1 because we don't have it here, so it will be okay. So let's just save it and try what happened. Just CLC clear and BGA. So as you can see, that's our code works. So let's see what's happened into the pop. As you can see, that's all position are just assigned here, and then with respect to the position, the cost functions are evaluated. So the cost field of any pop is just evaluated here. We here have a 4 for the first pop, and then we have 2 for the second pop. So according to the position for the all pops, the cost function just evaluated and is stored in the cost field. This is the end of this section, so let's just go to the next section.